Nirmala Rednam. In this video, I am going to explain the associative property for rational numbers from NCERT textbook class 8. In the previous videos, I explained the definition of rational numbers, closure property and commutative property. Now here, what do we mean by associative property? As we have done in the earlier properties, I am going to look at a set S and a mathematical operation. So given any set S and a mathematical operation, for any A, B, C belonging to the set, whenever A operation B operation C is equal to A operation B operation C, we say that the given mathematical operation is associative for the given set. Now here, the Bodmer's rule that we are familiar with comes into picture. That is, given any mathematical expression, the order of simplifying it is first you have to look at the bracket. So here for LHS, first you will be looking at B operation C, and then after simplifying this, you are going to proceed further. Whereas coming to the RHS, first you will be simplifying A operation B, and then whatever is the result, you will go ahead with that, right? So let's look at the associative property for the set of whole numbers. Okay. Associativity for the set of whole numbers. Right. So here, first I am going to take any three elements from the set of whole numbers. I am going to take 5, 3, 2. So now addition. 5 plus 3 plus 2. Okay. I want to compare that with 5 plus 3 plus 2. Are these two the same? Okay. Now this is 5 plus 5, which is equal to 10. Whereas this is 8 plus 2, which is again equal to 10. So yes, addition is associative for the set of whole numbers. Coming to subtraction, 5 minus 3 minus 2 as opposed to 5 minus 3 minus 2. Now what is this? This is 5 minus 1, which is 4, whereas this is 2 minus 2, which is 0. Now you can see here that subtraction is not associative for the set of whole numbers. Now coming to multiplication. 5 into 3 into 2 is equal to 5 into 6, which is equal to 30, whereas 5 into 3 into 2 is equal to 15 into 2, which is equal to 30 again. So you will see that multiplication is associative for the set of whole numbers. Now coming to division, 5 divided by 3 divided by 2 as opposed to 5 divided by 3 divided by 2. Now this is 5 divided by 3 by 2, which is equal to 5 into 2 by 3, which is equal to 10 by 3. Whereas here this is 5 by 3 divided by 2, which is equal to 5 by 3 into 1 by 2, which is nothing but 5 by 6. Now here these two are not equal. In fact, they are not even whole numbers. So you can conclude that division is not associative for the set of whole numbers. Now coming to the set of integers. Coming to the set of integers, associativity for the set of integers. Now again we are going to take any three elements. For simplicity, I am going to take the same element, simply put a minus for one of them, right? Now addition is 5 plus minus 3 plus 2 is equal to 5 plus minus 1, which is equal to 5 minus 1, which is 4, whereas 5 plus minus 3 plus 2 is equal to 2 plus 2, which is again 4. So you can say that addition is associative for the set of integers. Okay. Now next is subtraction. 5 minus 3 minus 2 5 minus of minus 3 minus 2. Let's compare these two. This is nothing but 5 minus minus 5, which is equal to 5 plus 5, because minus of minus will give me plus. This is 10. Whereas this is 5 plus 3, because again minus of minus is 10. So minus of minus is plus. So this is 5 plus 3 minus 2, which is equal to 8 minus 2, which is equal to 6. Now these two are not equal. So subtraction is not associative for the set of integers. Now coming to multiplication, I have 5 into minus 3 into 2, and this is 5 into minus 3 into 2. Now this is equal to 5 into minus 6, which is equal to minus 30, whereas this is equal to minus 15 into 2, which is again minus 30. You will see that multiplication is associative for the set of integers. Now coming to division. 5 divided by minus 3 divided by 2, 5 divided by minus 3 divided by 2. Now this is 5 divided by minus 3 by 2, which is equal to 5 into minus 2 by 3, which is equal to minus 10 by 3, whereas this is 5 by minus 5 by 3 divided by 2, which is equal to minus 5 by 3 into 1 by 2, which is equal to minus 5 by 6. You will see that these two are not equal. In fact, they are not even integers. So division is not associative for the set of integers. Now coming to our rational numbers. So here associativity for the set of rational numbers. Take any three rational numbers, right? Let us say we take 1 by 2, 2 by 3 and 3 by 4. Okay. Now let us look at addition. So I want to compare 1 by 2 plus 2 by 3 plus 3 by 4 with 1 by 2 plus 2 by 3 plus 3 by 4, right? Now this is equal to 1 by 2 plus, now here the LCM is 12, and here I am going to get 3 4s, 4 2s 8 plus 4 3s, 3 3s 9, right? Now this is equal to 1 by 2 plus 17 by 12. Now here again the LCM is 12. So 2 6, 6 1s is 6 plus 12 ones and 1 into 17 is 17. So this is 23 by 12, right? Whereas here I am going to get 2 3, the LCM is again 6, 2 3s, 3 1s 3 plus 3 2s, 2 2s 4 plus 3 by 4. This is equal to 7 by 6 plus 3 by 4. This is equal to, now here I want the LCM of 6 and 4. What is the LCM? 2 3 6, 6 2s 12. So the LCM here is 12. 6 2s, 2 into 7 is 14 plus 4 3s, 3 into 3 is 9. So here I am getting again 23 by 12. So it's the same thing. Addition is associative for the set of rational numbers. Now coming to subtraction. I have 1 by 2 minus 2 by 3 minus 3 by 4 and 1 by 2 minus 2 by 3 minus 3 by 4, right? Now this is 1 by 2 minus, I have the LCM is 12 here. Here it is 3 4s, 4 2s 8 minus 4 3s, 3 3s 9, right? Now this is 1 by 2 minus 1 by 12, which is equal to 1 by 2 plus 1 by 12, which is equal to, LCM is 12 to 6, and this is 7 by 12, right? Now what do we get here? Here again in the bracket the LCM is 6, 2 3s, 3 2s, 2 2s 4 minus 3 by 4, right? This is minus 1 by 6 minus 3 by 4. Okay. Now this is, I have the LCM 12, we've already done it, right? And I have minus 6 2 is 12, so minus 2, 4 3 3 is 9, so minus 9. So I'm getting minus 11 by 12, right? So you will see that subtraction is not associative for the set of rational numbers. Okay. Now coming to multiplication, I have to compare 1 by 2 into 2 by 3 into 3 by 4 with 1 by 2 into 2 by 3 into 3 by 4, right? Now this is, I can cancel this, 2 ones, 2 2s, so this is 1 by 2 into 1 by 2, which is 1 by 4, whereas here I can cancel this 2, this is 1 by 3 into 3 by 4, which is equal to again 1 by 4, right? So multiplication is associative for the set of rational numbers. Now coming to division. So here I have 1 by 2 divided by 2 by 3 divided by 3 by 4, and here I have 1 by 2 divided by 2 by 3 divided by 3 by 4, right? So here I'll get 1 by 2 divided by 2 by 3 into 4 by 3, I'm taking the reciprocal, right, which is equal to 1 by 2 divided by 8 by 9, which is equal to 1 by 2 into 9 by 8, which is equal to 9 by 16, right? Whereas here I'm going to get 1 by 2 into 3 by 2 divided by 3 by 4, which is equal to 3 by 4 divided by 3 by 4. This is equal to 3 by 4 into 4 by 3. Now this is again equal to 1, right? So here you will see that division is not associative for the set of rational numbers. So with this we have checked the associative property for the set of whole numbers, for the set of integers, and for the set of rational numbers, right? Now let's quickly look at what is given in the textbook. So here they have given whole numbers, so they have checked and they have left a few blanks which you can do as an exercise. They have checked for a few numbers and they have concluded addition is associative, subtraction is not, multiplication is associative, and division is not associative for whole numbers, right? Next, coming to integers, again they have taken a few examples here and they have concluded just like us, addition is, subtraction is not, multiplication is, and division is not associative for the set of integers. Now coming to rational numbers, they have again taken a few examples and shown you the calculations as well. Here again they have concluded addition is associative, subtraction is not associative, multiplication is associative, right, and division is not associative. Okay, so we have got the same result, right? Now here they have given a table. Let me highlight this. Division is not associative, right? Now here they have given a table for us to fill where we have done all this already. So let's just quickly look at this. Addition, for all four sets we have seen that it is associative. Subtraction is not associative for all four sets. Multiplication is associative for all four sets. Division is not associative for all the four sets, right? Now let's move on to the example. Before I explain the example to you, I would like you to again revisit the table that we had filled for commutative property and see the similarity. That is, if you remember, we have seen that even for commutative property, it's a yes for all the four sets when it comes to addition. It's a no for subtraction, yes for multiplication, and no for division. So this is basically, you need to realize that these two properties are, for the given four sets that we are considering, they it depends more on the mathematical operation than on the set, so to say, right? So if you remember, we had done an activity for the commutative property for the all the 4 operations and all the 4 sets, right? So now here I want you to check this activity for associative property as well. So if you see, for example, if you take rational, okay, rational set of rational numbers RATIONAL, and then you choose any of the properties, any of the operations here, let's say addition, and then open and see, it's a yes. That means addition is associative for the set of rational numbers, right? Now I have a question. Can you do this same model for closure property? Okay, if yes, go ahead and do it. If no, then I want you to think about what is the reason that this model does not work for closure property, right? Now let's move on to the solved examples. So here in the solved example, they have given 4 rational numbers and they want us to simplify this, right? So let us go ahead and do it. Let us take the question, note down the question first. So if I look at the example 1, okay, what do we have here? 3 by 7. I have 3 by 7 plus minus 6 by 11 plus minus 8 by 21 plus 5 by 22, right? Now here, how are we going to solve this? If you see here, they have taken the LCM of all the denominators and they have proceeded, right? You will see that you will get the answer minus 121 by 462. Whereas instead of taking the LCM for all the 4 numbers, if you were to group them in the sense, if you rearrange them, can you rearrange this as you take this term, bring it over here and bring this term here? What are we doing? I am simply writing a plus b as b plus a, right? Is this allowed? This is allowed because we know that addition is commutative for the set of rational numbers. Now why are we doing that? If you look at the denominator here, 7 and 21 belong to the same table and finding the LCM is very easy. The LCM is 21, right? Whereas again here 11 and 22 are 11 2s is 22, so LCM is going to be 22. It is simpler to find it rather than finding the LCM for all the 4 numbers together, right? So that's what they have done here, and then they are going to simplify it further and you will get the answer quite very easier in a simpler manner compared to the earlier method of finding the LCM for all the 4 rational numbers and then proceeding. So here we have used the commutative property as well as the associative property, right? Now where have we used the associative property? Here I am taking this into a single bracket, right? I am first rearranging them, that is commutative property, and then taking them into a single bracket, that is the associative property, right? So you will get the answer in a much easier manner. So do you think the properties of commutativity and associativity make the calculations easier? Yes, they are making the calculations much easier, right? Now going to the second solved example. Here what they have done is, again they are using commutativity and associativity. So you have the, let me note down the question, minus 4 by 5 minus 4 by 5 into 3 by 7 into 15 by 16 into minus 14 by 9, right? So now here, in order to simplify this, one way is you are going to find the numerator 4 into 3 into 15 into minus 14, and then the denominator 5 into 7 into 16 into 9, right? And then you will simplify it. Or you can again, like in the earlier case, you can again group them so that the cancellations become easier and then simplify it, right? So here in the first method, what they have done is taken them as it was given to them, right? They've taken these two at a time and these two at a time, and then found out this 4 into 3 minus 12, and then 5 into 7 is 35, and so on. Whereas instead what they have done here is they have used the commutative and associative property. That is, they have taken this term to the second place, that is minus 4 by 5 into 15 by 16, and group them using associative property. 3 by 7 into minus 14 by 9, again group them using associative property. Now here you can easily cancel this, right? And you will get minus 3 by 4, and here again you can cancel this and you will get minus 2 by 3. Now you can see how the use of commutative and associative property has made our calculations very easy, right? Now with this we come to the end of associative property for the set of rational numbers. So in the next video, I want to demonstrate an activity just to look at the associative property. Why is it holding true for some operations and why it is not holding true for some operations, right? So we will be doing that activity in our next video.